Okay, so we're back talking about section 7.2, continuing where we left off. There were some practice problems for you to try. The last thing we talked about, just to remind you, we talked about how that if you measured 1 centimeter, which this is bigger than a centimeter, but just so you can see it, 1 centimeter for your length by 1 centimeter for your width, then we multiplied 1 centimeter times 1 centimeter. We would call that space occupied, that two-dimensional space, a square centimeter. All right, now a centimeter is the same thing as 10 millimeters. There's a difference of 10 between, on our scale that we talk about to get from centa to milli, just one place different from there. There's just a factor of 10 between each move on this linear scale that we talk about. So we can say that a centimeter is the same thing as having 10 millimeters. So we could say this is 1 centimeter. Also, we could say it's 10 millimeters, equivalent measures. So if we do the area by multiplying the 10 by 10 millimeters times 10 millimeters would make 100 square millimeters. So we can say that those are equivalent measures. A square centimeter is the same thing as 100 square millimeters. Those are equivalent. So it looks like there's 2 decimal moves now. 1 decimal move for each dimension, the length and the width dimension, makes 2 decimal moves to get one place like centa to milli on this scale. So when we look at our scale, remember the base unit meter, liter, and gram are our base units. Then we have prefixes, deca, hecto, kilo. And as we go down the scale, smaller measures are deci, centa, milli. So if we were going like on number 9 from square centimeters to square meters, we would be going from centa to regular meters, which is 2 moves up. But up moves a decimal to the left, and I'm going to double those moves. It's 2 moves for every place. So 2 moves there, 2 moves there, makes a total of 4 decimal points from my understood decimal. 1, 2, 3, 4 makes 0.0005 for that first answer. Number 10, we're going from square meters to square centimeters. Also 2 moves. I hope I have some variety here. Square meter to square centimeter is down the scale, and again it's 2 moves, and we decided 2 moves, we double that, it makes 4 moves because there's 2 moves for every move on the scale when it's square units. So down means right, so we take our decimal point that's given, 1, 2, 3, 4, and that's 53,000 for our answer to number 10. Number 11, we're going from square kilometers to square meters. So that's mixing it up a little bit. All the way from kilo up here at the top, kilometer to regular meter is 1, 2, 3 moves down. So down moves the decimal to the right. And because it's square units, we're doubling that. Doubling 3 would make 6. So we're taking this decimal 1, 2, 3, 4, 5, 6 places, filling in zeros as needed. So 1, 2, 3, 4. What is that? 10,930,000. If you were going to change square kilometers, a very big measure, into square meters, there'd be a bunch of them in meters, right? So that kind of makes sense. All right, next thought is volume. So we talked about area. Area is 2-dimensional, a length times a width, filling in the 2-dimensional flat space on something like a piece of property, the flat space there, or if you're painting a wall, or this marker board, the area on this board. I would take the length of the board times the width of the board. That would be the area of this board. But if we go 3-dimensional space, then we're going to have volume. So it says when a figure has only 2 dimensions, length and width, we can find its area. When the figure has 3 dimensions, length, width, and height, we can find its volume. The volume of an item can be considered the space occupied inside that item. The base unit of volume in the metric system is the liter. In all other English-speaking countries, they spell a little different. You can see there on your notes. And a liter is a little larger than a quart, if you know what your quart jars look like if you can beans. Liters are used in place of pints, quarts, and gallons, and a liter divided into 1,000 equal parts. You can kind of visualize a liter and divide it by 1,000, that's a milliliter, so a very tiny measure, milliliter. All right, so for your activity 12, I requested that try to draw this out using your measuring stick that I'm hoping that you all have somewhere in your house. draw a decimeter. So a decimeter is maybe about like that distance, and make it a cubic. These are not necessarily that easy to draw, but we're going to have length and width. Not only that, have you ever done this where you kind of draw the two boxes to give it a third dimension? You artists out there will be much better at this. But let's give it a height, like how far out it goes that way, a third dimension, and make it have length, width, and height. So maybe think of this as being your length, your width, and the height. It doesn't really matter which one you call which. You could turn it on its side and different things. But a 1 decimeter by decimeter by decimeter, inside of that would be a cubic decimeter. 1 decimeter times 1 decimeter. I try to make this not perfect, but should be in the ballpark of a decimeter times a decimeter times a decimeter. 1 times 1 times 1 would be 1. Decimeter times decimeter times decimeter is decimeter to the third. So we call that cubic decimeter, a cubic decimeter. And it just so happens that a cubic decimeter holds a liter of liquid. You know, a liter is a liquid measure. Decimeter is a solid measure, a length there, but this would be liquid, like how much liquid could be put inside of this. If this was a cup or a metal container, how much liquid could we pour in it? A liter. So that's exactly what a liter is. And we'll talk about that a little bit more in a minute. Which I guess that's at the end of that page. All right, so next page, we will talk about that right now. So that's a conversion, just something to be aware of, that a cubic decimeter is a liter. And furthermore, a smaller measure, the cubic centimeter, which is a smaller measure, you know, a tenth of that, a centimeter by centimeter by centimeter, a little maybe like sugar cube, that would be a milliliter. It would hold a milliliter of liquid. And then a bigger measure, a cubic meter, would be a kiloliter of liquid. I did note this because I used to buy mulch at the mulch store, and they showed it in cubic meters, which I thought was kind of interesting. I don't necessarily see that measure out and about that much, but at the Scooping Up mulch store, I don't know if you've been there or have experienced this, but they sell mulch in a scoop that's a meter by meter by meter. So, you know, a meter is about the length of my wingspan, and then a little further out to the 3 inches further than a yard. So if you can kind of visualize, if I go that far, my wingspan, tall, and, you know, by the 3 dimensions, and fill that in with mulch, that's how much you got in the cubic meter scoop. Anyway, if it was filled with liquid, it would hold a kiloliter in liquid, though. Just to kind of give us a thought on that. Medicine droppers note that a cc is the same as an ml. If you've ever had to give a little one, maybe Tylenol or something, you might notice on the little medicine scoops that a cubic centimeter, which they call a cc, stands for cubic centimeter. A cc and an ml are in the same place on your little medicine scooper because they are equivalent measures. And then think of other things maybe you've experienced. Those would be various ones for each of us that maybe you've experienced in the medical field or other fields that you're in. All right, so the last thing we need to be able to do is convert things like number 13, 1 cubic meter to cubic centimeters. So the argument I made a little earlier on the video about converting square units, if it's 2-dimensional, you have to move 2 decimal places. You might kind of know where I'm going with this. It's going to be the same thing. When we're doing cubic units, it's going to be 3 decimal moves. It's a difference of 10 by 10 by 10 for every place you move on the metric scale. If you're trying to get from meter to centimeter, it's 2 places. For meter, there's deci and then centa. So it's 2 moves on our conversion chart. And we know normally in linear units, if these 3's weren't there, we would just say from meter to centimeter is 2 moves down. It's going to move my decimal 2 places right. But if it's square units, you have to double those moves. And if it's cubic units like this, cubic units, we're going to move 3 places for every move on that scale. So again, let me remind you of your scale. We've got our basic unit, meter, liter, and gram. And then we've got deca, hecto, and kilo. Down the scale, we have deci, centi, and milli. So if we're converting from cubic meters to centimeters, we start at meter, it's down to go to centi, 2 down means go right, and you triple that. It's 3-dimensional, so 3 decimal moves, 1,000 difference between meter and deci in cubic units. So we're moving a total of, 6 places. From the decimal point, which is right here, 1, 2, 3, 4, 5, 6, which looks like we just added 6 zeros on that example. All right, please pause the video and try 14 and 15 before I reveal the answers. So on number 14, I'm going from millimeter, so down here up to dm is a deci, so that's 2 up. When I move up, I move my decimal to the left, up is left. The decimal is here. Because it's in cubic units, I'm tripling the moves. So even though it's 2 places, I will triple that. 2 times 3 is 6. So 1, 2, 3, 4, 5, 6 is 0.00000, 5 zeros, 1. Okay, then lastly, 1 hectometer cubed to kilometer cubed. So they're both in cubic units. So I'm going from hecto to kilo. So not very far, just 1 move from hecto to kilo is up the scale 1 place, but we triple every move. So that will be 1 times 3 or 3 moves. Up is left from the decimal here, 1, 2, 3. So 0.001. All right, so we will pick up on that discussion, take it a little further in section 7.3.